Hello, welcome to today's lesson. We're going to continue our work with logarithms. If you're in Algebra 2, this is section 6.5. And if you're in pre-calc, this is section 3.3 in your textbook. And what we're going to be looking at are properties of logs that we can use to expand and condense logs. Algebra 2 got a preview of this in the last lesson, but I'm going to review the preview with you because I think it's worthwhile since it's the first time you're seeing this. If you're in pre-calc, you haven't seen this since last year. So we're going to work today to expand logs, and then next lesson we're going to condense logs. We have three properties or rules here, and we have some noted restrictions. So just to mention for the restrictions, if you recall, for logarithmic and exponential functions, we had restrictions on the base of a. The restrictions on the base of a are that you can't be 0, you can't be negative, and you can't be 1. So that's why this is written here. And then as far as the part that says u greater than 0 and v greater than 0, if you look here, see how u is inside the log and v is inside the log? If you recall, the domain for log function is x greater than 0. So you're not allowed to put 0 or a negative here. So that's why these are here. And you guys don't have to worry about these restrictions very much. You're not going to have to do anything with them. I'm not going to try to fool you with that. But I want to put it there because you'll see that in the textbook. And for these properties to work, these technically have to be satisfied. So here are the three properties. I call them 1, 2, and 3. They don't have official numbers associated with them, but it's going to be easier to discuss them if I refer to them as 1, 2, and 3. Property 1 says if you have log of a product. So if inside the log you're multiplying two things, you can split that apart. You make two different logs that have the same base as before. So log base A, whatever that base was. You put the first factor inside the first log. You put the second factor inside the second log. And that's considered expanded. If you have log base A of a quotient or a fraction with a u over v perhaps, you can separate that into two separate logs. You put a minus. So you're going to subtract two different logs. You keep the base. So whatever the base is, that stays the base for all the other logs. Whatever was in the numerator goes inside the first log. Whatever was in the denominator goes inside the second log. And then the third rule says, if you have a log and you have an expression that has an exponent inside, you can actually take that exponent, swing it around to the front, and make it a factor. And make whatever that exponent was, make that a regular number times the log of, in this case, u. And we're going to see all these properties in action. So today we're going to expand. And when we expand, we use the properties going this way, from left to right. The next lesson, we're going to condense, where we take from this side, we take a sum of two logs and make it one log, or difference of two logs and make it one log, and so on. But that'll be the next lesson. For today's lesson, we're just going to do expanding. So let's begin with some one-step problems. Okay, here's my first one. Oh, and by the way, if you're in pre-calc, you should take a moment, pause the video, and write down these rules. You want these in your notes. Algebra 2, you wrote them down last time. Okay, so this is a one-step problem. We want to expand. This log has a base of 2. When you look inside, you want to ask yourself, do I see a product, a quotient, or a power? We see a product because that's x times y. So rule 1 says I can rewrite this as two separate logs. I keep whatever the base is. I'm going to be adding those. So it's log base 2 and log base 2 because I keep the base. The first factor goes inside the first log. The second factor goes inside the second log. And that's it. That's considered expanded. That was a one-step problem. There's no work to show. We're done with that one. For the next one. The next one is log base 3 of a over b. So what you want to do when you're expanding is you want to look inside and ask yourself, do you see a product, a quotient, or a power? You can even write down that question in words off to the side. Do I see a product, a fraction, or a power inside? We see a fraction, so we're going to be applying rule 2. Feel free to write down the rule you're using. Some teachers would require that. I don't require it, but if you want to write down that you're using rule 1, rule 2, whatever it is, that's fine. So since we have a quotient in here, what we're going to do is we're going to write two different logs keeping the same base. We're going to put a minus in between them. Whatever was in the numerator goes inside the first log. Whatever was in the denominator goes inside the second log. So it's going to be log base 3 minus log base 3. Whatever was inside the first, whatever was the numerator goes inside the first log. Whatever's in the denominator goes inside the second log. And that's it. And for our third of these one-step problems, we want to look in here and see if we have a quotient, product, quotient, or power. We have a power. And just to make note, when you have a log like that, the base here is 10. That's our common log. What is inside the log is the w to the fifth. So if there's no parentheses at all, we assume that that w to the fifth is inside. And I'm mentioning that because I don't want you to think it's this. That 5 belongs to the w and only the w. It does not belong to the log of w. So if there are no parentheses written, it means this. Okay. And what Rule 3 says is that we can take that exponent and swing it around to the front. So I'm going to take that 5, swing it around to the front. It should be the same size, same height as log. And then log just has w inside now. So instead of being an exponent for w, it becomes a factor or coefficient of sorts, and you're multiplying it times the log of w. And that's it for that problem. So what we're going to do next is we're going to continue our work, but we're going to start to do problems that are a little more complicated, that are going to be more than one step. So here's our first problem. And I'm going to continue to keep these properties up top the whole time. So if you end up having to turn your page, they'll be here so you can refer to them. Okay. So here's our next problem. We want to expand this. And I'm going to ask you at this level to show at least one step of work. Okay. Because what you're going to find is some of you, believe it or not, will actually look at this expression and know what the final answer is before you even write down any work. But since we are learning it, I'm going to require work in Algebra 2 and in pre-calc, at least one step of work for these. When you get to calculus, I won't require work for this type of problem, but for Algebra 2 and pre-calc, I'm going to ask you to do that. Okay, so we have log base 3, and when you look inside the log, you want to ask yourself, what do you see? Do you see a product? Do you see a quotient? Do you see a power? I see 2 of those things. I see a power. I see a 2. Who does that 2 belong to? Does it belong to A and B or just B? It's just to the B. A doesn't have an exponent, so if we want to put an exponent, it would be A to the first. Just to mention. So we have a power. We're definitely going to have to use Rule 3. And the other thing we have is a product, because it's A times B. We don't have a dot there, but we could write a dot. It's A times B squared. So we're going to be applying Rule 1 and Rule 3. Now, the question that we have to ask next is, do we use Rule 1 first or Rule 3 first? For this problem, it has to be Rule 1. Now, one thing that might bother you as we proceed with our examples is when you are using multiple rules, sometimes it doesn't matter which one you do first. Sometimes if you're using 1 and 3, sometimes you have to use 1 first. If you're using 1 and 3, sometimes you have to use 3 first. So I cannot give you like a standard, always do a certain sequence. It's going to depend from problem to problem. So that's something I'll be mentioning as we proceed. So the reason we have to use Rule 1 first is because we can't use 3. Remember before I asked you who the 2 belongs to? It only belongs to the B. So I can't take that 2 and swing it around to the front because that exponent is supposed to belong to whatever's inside the log. And that 2 only belongs to the B. It has nothing to do with the A. So we can't use Rule 3 first. We have to use Rule 1 first. For Rule 1, we have to identify a first factor and a second factor. Our first factor here is A. Our second factor here is B squared. So what we're going to do is we're going to write log base 3 and log base 3. Whatever the base is, we keep it. We're going to put a plus. And what goes inside of the first log is the first factor. So the first factor here was A, that goes inside the first log. What goes inside the second log is the second factor. The second factor here is B squared. So we have successfully applied Rule 1. So if you want to write, sometimes people do this, sometimes people write an equal sign and write above it what rule they're using. So we used Rule 1. Now we're going to use rule 3. So if you want to show what rule you're using, that's kind of a nice way to do it. And we're going to use rule 3 on this one here. We're just going to copy log base 3 of a. We're not going to do anything to that one. We're going to copy the plus. And then for the second log here, we're going to apply rule 3. So focus on this log. What we're going to do is take the exponent and swing it around to the front. So I'm going to take the 2 and swing it around to the front of this log. Not this one over here. It has nothing to do with that. Just this guy. So the 2 is going to move around to the front. And then we're going to keep the base of 3 and just b is inside now. We are finished with this problem. Here's how you're going to know you're finished when you're expanding. When you look inside each log, you want to make sure that you don't have any more products, quotients, or powers. So inside this log, do you see a product, a quotient, or a power? No. Then we're finished. Look inside this log. Do you see a product, quotient, or a power? Do you see a multiplication problem, a fraction or division problem, or an exponent? No, I don't see any of those things. That's how we know we're finished. Okay, we have more examples to do. And remember, you can always go back and rewatch any of these. So if anything I did was a little too fast, or if you just need a moment to review it, you have the ability to go back and rewatch. So here's number 5. Okay, we want to expand this log. So this log is base 4, and then I have cube root of x over y. So to expand this, we want to look inside and say, do we have any product, any multiplication problems? Do we have any division or problems or fractions? And do we have any powers? Well, if we rewrite log base 4 instead of as cube root, if we rewrite that with a 1/3 power, then you will see that we have a fraction, that's the x over y, and we have an exponent, that's the 1/3. So the 2 rules we're going to use are 2 and 3. We're not going to use rule 1 this time. So for this problem, we're going to use rule 2 and rule 3. And again, these are not official names. It's just easier to refer to them as 1, 2, and 3. So looking at this problem, this is a problem where, well, let me ask you, would you do rule 2 first or rule 3 first? This is a problem where you can actually do either one first, because what you can do is, I'm leaning toward rule 3 first. I'll show you the other way in just a minute, okay? So I see that this entire quantity is being raised to the 1/3 power. So what I can do is I can swing that 1/3 around to the front in front of the log, just like here. Hang on, let me adjust here. Okay, thanks. So a little bit more. There we go. So I can swing that 1/3 around to the front, and then I have log, I keep the base of 4, and then what's inside is the x over y. So I just applied rule 3. I just swung that exponent around to the front. Now when I look inside, I still have a quotient. That's how I know I'm not finished. So what we have to do next is we have to apply this rule here. So what we're going to do is we're going to keep log base 4, but we're going to write 2 separate logs with a minus in between them. And what goes inside the first log is the x, and what goes inside the second log is the y. The numerator goes inside the first log, the denominator goes inside the second log. And we have to be careful because what I have written right now is actually incorrect, because that 1/3 belonged to this entire log. So when we split this up, the 1/3 has to belong to both logs. So I used brackets here, but you totally could put parentheses if you want instead. So if you'd be more comfortable with parentheses, you can do that. And you need to distribute that 1/3. So we have 1/3 log base 4 of x minus 1/3 log base 4 of y. And that's our final answer. I know that we're finished because when you look inside the log, I don't see multiplication, division, or exponent. So this log's done. When I look inside here, I don't see multiplication, division, or exponents. So this log's done as well. Now that was one way to do this. Just to offer you an alternate, So the way that we did this is we used rule 3 first, and then we used rule 2, and we were careful because the 1/3 had to go to both the logs because the 1/3 belonged to the entire quantity. Another way to do this is to use a property of exponents first. So for anyone who looked at this and said, hey, can't I make this x to the 1/3 over y to the 1/3? Yes, you can. It's correct. So that's a property of exponents that we know since Algebra 1. And what we can do now is we can apply rule 2 first instead of rule 3, because now we can take care of this division first. So take a peek at rule 2. We're going to do rule 2 right now. Okay, so rule 2 says we're going to take log and keep the base. We're going to make 2 of them and subtract. Inside the first log is the whatever was in the numerator. Inside the second log is whatever was in the denominator. And we're not finished because when you look inside, do you see how you have an exponent? See how you have an exponent? So what we have to do now is we have to apply that rule 3. So we're going to take the 1/3 and swing it around to the front of just that log. Now only x is inside because I moved the exponent. And then we're going to take this 1/3, swing it around to the front, and now only y is inside because I moved that exponent. And if you notice, we have the same exact answer. So you can do this either way, and you don't have to do the problems 2 different ways. You just have to have one way to successfully get to your final answer. So those of you who liked this way better, then you can stick with that. Those of you who preferred this way, that's fine. Just be careful with those parentheses or brackets if you do have a number in front and then you expand further. Okay. Up next is number 6. Okay, so this time I selected natural log. That's log base e. And inside I have wz and I have over y. So take a look what rules we'll be using. We're going to be using rule 1 and rule 2. We're definitely using rule 1 because I see a product. I have w times z. We'll be using rule 2 because I see a quotient. I have a fraction inside there. We won't be using rule 3 because there's no exponents. It's up to us what we want to do first here. This is one of those problems where we have 2 rules we're going to use. We're going to use rule 1 and rule 2. And it's up to us which one we want to do first. So what I would do in this one personally is use rule 2 first. And here's why. When you look at this problem, can you easily identify a numerator and a denominator? Yes. The numerator is wz, the denominator is y. So that's why I would go to rule 2 first with this particular problem. You can use rule 1 first, but rule 1 would be trickier because when you look at this problem, can you easily identify 2 factors, a first factor and a second factor for the whole problem? No, not really. In order to do that, you'd have to do some algebraic work on this. And I can show that in a minute for anyone who's interested. But let's go to rule 2 first, since we could identify a numerator and a denominator. So rule 2 says we're going to keep log with the same base. So it's going to be ln, natural log. I'm going to keep a minus. Whatever the numerator was goes in the first log, and whatever the denominator was goes in the second log. Now when I look inside, this one here I have multiplication. So this one I'm going to have to use rule 1 on. This one here is finished, this log, because inside I don't see multiplication, division, or power. So what I'm going to do with this log, so I'm focused right now on log of w times z, and I'm going to apply rule 1 to that. Okay, so we keep log and log, because we do log with the same base as before. I put a plus. The first factor is w, the second factor is z. And then we bring down the minus, and we copy that minus down here, and we copy the natural log of y. And we're finished. So our final answer is here. And we know we're finished because inside there's no multiplication, division, or power inside any of these logs. Just to show you, so if you're satisfied with that, you're good on number 6. But just to show you, for anyone who thought about using rule 1 first, you can do it. But what you'd have to do is you'd have to start by splitting up this product. I don't think you'll like this. You'd have to make it w over y times z in order to see first factor, second factor. Or you could make it w times z over y to see first factor, second factor. And I think right there I've probably convinced you don't want to do that. I think it was easier to identify a top and a bottom. The top goes in the first log, the bottom goes in the second log. If anyone wants to see this worked out further, let me know. I'd be happy to write it out or record it for you. All right, so that's number 6. Here comes number 7. Okay, for number 7, we're being asked to expand. So when you look at number 7, are you thinking rule 1, rule 2, or rule 3? The answer is it's kind of a trick question. You can't expand this one. Okay, so when you look inside, you don't have a product. You don't have multiplication. You have x plus y, not times. You don't have division. You have x plus y, not x divided by y or x over y. And you don't have an exponent. So when you have a log of a sum or a log of a difference, you can't expand it. We don't have a rule for that. You can write down those words if you want. We don't have a rule for this. Now, I know it can be confusing because it looks like it's maybe similar to this, but this is different. Because look at this expression. How many logs? That's 2 different logs. When you look at this expression, it's only 1 log. And I think I'll leave it at that for that problem. We could discuss that further, but I don't want to hit you with too much in one day. So we'll discuss that another time. And we have one more example for pre-calc. And let's take a look at this one. So we have natural log again, that's log base e. And our numerator is x plus 1, our denominator is y to the 4th. Think please about which rules you'll be using. 1, 2, 3. You will be using rule 3 and rule 2. We're not going to use rule 1. There's no products in there. We have a quotient because I can see a numerator and a denominator. And I have a power because I have it to the 4th. But there's no product. There's no multiplication in this problem. So for rule 3 and rule 2, for this problem, we have to use one of these first. Do you know which one it is? It's rule 2. We have to use rule 2 first. We can't use 3 first because rule 3 would be swinging this 4 around to the front. We cannot do that first because the 4 only belongs to the y. It doesn't belong to the top. So what we have to do first is we have to split this up using rule 2. So we're going to keep natural log and natural log. We're going to make minus. Inside the first log goes x plus 1. Inside the second log goes y to the 4th. We're not finished, but before we continue, I want to make note what I have written is incorrect. We need to put parentheses around that x plus 1. Because if you don't have the parentheses, what this actually means is taking the log of x and then like randomly adding a plus 1 at the end. So since the numerator was x plus 1, even though it didn't have parentheses when it was in this fraction, it has to have parentheses when it's inside a log. So if you have an expression with more than one term, so a binomial or trinomial inside a log, it requires parentheses because this would be different. I mean, this can happen in other problems, but it's different. It's not the same as this. We want x plus 1 inside that natural log. Okay. And now we've applied rule 2. So for anyone who likes that to write down what you did, that's rule 2. And what we're going to do next is use rule 3. So this log cannot be expanded because of what we saw in the previous problem. This log cannot be expanded because inside it's a sum. It's not a product, quotient, or power. Okay, so no rule for expanding that. But the second log, we do have a rule for that, rule 3, because we can take that 4 and swing it around to the front. We don't put it in front of the other log. It only goes in front of this little guy here. And that 4 is now the same size because it's 4 times natural log. And now what's inside is just y. And there's our final answer.